Section 2.4, rotations. Here we go. Now, rotation. You can either turn something counterclockwise, or clockwise. Clockwise goes this way. Counterclockwise goes the opposite way of a clock, which goes this way. Now, a rotation, which is turning something, is a transformation in which a figure is rotated about a point. Now, right now, we're going to start rotating about the origin. But I could say rotate around the point 1, 1. Or rotate 60 degrees clockwise around the origin. So the number of degrees a figure rotates is the angle of rotation. So as you see here, this angle of rotation is going clockwise. And the point at which it turns is called the center of rotation. This is also a rigid motion. So in a rotation, the original figure, which is the pre-image, and its image are congruent. Example 1. I want you to rotate the puzzle piece 270 degrees clockwise about point P to fit into a puzzle. Which piece fits into a puzzle? Well, what you're going to have to do is rotate this puzzle P, or rotate this around point P. This is not easy. I know it sounds like pretty easy, but it's not. So if I take this and I rotate it, so let's think. Clockwise is this way. So if I go point P, notice that point P doesn't change. I'm not doing this. That's not, you notice how point P is changing there? Point P, that means that stays still. So, there's 90 degrees. There's 180 degrees. There's 270. So which one of these matches 270? It would be C. Once again, if I said this is where it gets confusing. Let's say I said this. This is point A. If I said to rotate 90 degrees around point P, it'd look like this. Point P stays put. But if I say rotate around point A, 90 degrees, point A stays put, 180, 270, and then we're right back to where we started for point A. So that's just kind of a way to look at it in the future, is we're going to be rotating around different points. And here's another way to look at it. This. When rotating a figure, it may help to sketch the rotation in several steps, or you can actually turn your paper. So this would be about point P. Notice that point P stays put. Now, the other way to look at it is this is actually 90 degrees counterclockwise. So 270 degrees clockwise is the same as 90 degrees counterclockwise. Now, I already have all the answers written down on this one, but let's go over it. The vertices of a trapezoid are these 4 points. So as you can see here, you would draw trapezoid W, X, Y, Z. And then I want to rotate it 180 degrees about the origin. So notice what happens. 180 degrees. This only works for 180. Notice that I didn't have to say clockwise or counterclockwise, because you would end up in the same spot, and that's what it says here. 180 degree clockwise rotation and a 180 degree counterclockwise rotation have the same image, so you do not need to specify which direction you are going in 180 degrees. So I rotate it. Now you could actually take this entire thing, and if you want to turn it, notice where the red shape goes. It overlaps on the blue shape. So W rotates this way, becomes W prime, X, and so on. Notice this only works for 180 degrees. Look at what happened to W. W became W prime, and that point is 4, -2. We'll do one more. X was -3, 4, and X prime became 3, -4. What's happening to your ordered pairs? If you start with XY, the X becomes the opposite. You take the negative X value. And Y becomes the opposite. So all you do is take the opposite of the current x and y value. Example 3. The vertices of a triangle are as given. I want you to rotate it 90 degrees counterclockwise about vertex L. What are the coordinates of the image? I know this sounds so much fun. But first, I'm going to put graph paper on here. And it should appear anytime. It's going to appear right now. Here we go. I'm going to graph in, let's do red. 1, 2 is J. K is 4, 2. 1, negative 3 is L. Here it is. Now, I'm not rotating about the origin. Let's say I did rotate about the origin. I will tell you, though, this is what it's going to be. Well, no, let's not do that now, because it's going to be overlapping. Let's do blue. About point L means a 90-degree turn is going to go this way. L prime actually is the exact same point. And J, let's see if we count 1, 2, 3, 4, 5. That means we go this way. 1, 2, 3, 4, 5. So J prime becomes right there, and K goes 3, 1, 2, 3. That is K prime. Notice it moved 90 degrees counterclockwise. Let's say I did do about the origin. If I went about the origin, it would be, let's see, this would be J prime. Let's see, 3, 1. This would be L prime. This would be K prime. If I rotated this about the origin, notice the origin is staying put. Look at where the red ended up. I'll do it again. The red, if I turn it about the origin, that's where I drew in green. But I moved point L. Point L went this way. So it became the blue. Point L rotates about point L. Origin rotates around the origin. It's confusing, but it's a concept you have to understand. Now, we are now going to use more than one transformation. So I'm giving you these vertices which are in red. Triangle ABCD are in red. I want you to rotate the rectangle 90 degrees clockwise and then reflect it on the y-axis. So notice here, here's what happened. It went 90 degrees up. It turned. It went just like that to get the blue one. So now, once we did that, we reflect it over the line of reflection, which becomes the green. And so the green, which is A double prime, B double prime, C double prime, D double prime, we want the vertices of those points, which would be that. Now, before we start number 5, let me tell you something. This is only one possible answer I'm giving you. There are many. I want you to tell me how I could take this red shape and move it to the blue shape. Give me a sequence of transformations in which the blue figure is the image of the pre-image of the red figure. So here's what I'm going to do. I'm going to start by turning the red figure 90 degrees. Counterclockwise. Notice what happened right here. Here it is. It swung up 90 degrees counterclockwise. And then you can see it here. It's right here in the dotted line. Then we slide it up. We translate it up. Well, how many units? 1, 2, 3, 4. Up 4 units. So you can't just say rotation, then translation. You must say a 90-degree counterclockwise rotation about the origin, followed by a translation of 4 units up. Now, someone may say, Mr. Humphreys, instead of 90 degrees counterclockwise, could I say 270 degrees clockwise, then translate up? Absolutely. You could also say clockwise 270 degrees about the origin, and then slide up 4 units, which would be a translation. Here are your 3 vocab words for this section.